Welcome to SOLIDWORKS Refresher and Design for Manufacturing. My name is Alec Cook. I am an application engineer with GoEngineer. My email is down here on the bottom. Feel free to write that down, take a screenshot, note it, because if you guys want a voucher for the CSWP or CSWA, I can have some of those generated for you guys. All right. So, a little background on myself. I spent 5 years in metal fabrication before I went back to school at ASU. I would say, three different types of metal fabrication. I did structural work. So, I did a lot of steel work for some mines here locally. And that's just heavy, thick gauge metal for big buildings, and it's like kind of the webbing of a building. That's really structural fabrication that I did. And then I spent about a year doing ornamental fabrication, and that's probably where I learned 90% of what I know about metal fabrication and making things. And then I did a little bit of time working with aluminum in Florida doing some spiral staircases. Once I started working for GoEngineer, I became a certified SolidWorks instructor, so I teach different topics here. In particular, I like to teach weldments and sheet metal. I teach also essentials. Also, we are a reseller of 3D printers and 3D scanners, so that's been really fun. And I ended up purchasing my own little 3D printer, and I get to design things and create things inside of SolidWorks, and then 3D print them. And when I say solve problems around the house, I just basically find little things that I want to change, and I can fix with a 3D printer. Here's a perfect little example of something that I had created. These are the Google Home Minis here that I use to control my house, or certain things in my house. Like I turn on my TV, I can place like a phone call from it. Recently, I discovered I have a Google Pixel as well, so from anywhere, I can just say broadcast, and then whatever the next thing that comes out of my mouth will just be broadcasted through all the speakers in my house, which is pretty fun. So the problem was though that they sit on a countertop, and there's a cord, and this cord's like 6 feet long, and it kind of every time I'd pick it up, it would just unravel into this rat's nest. So I was annoyed with it being on the countertop, and I felt that it would pick up my voice better being vertical like that. I came up with the design, took a picture of it, created a sketch, added a few features, and I added a little area on the back to wind the cord around so it's organized a little bit better. And then I just mounted it in to the wall there. So this is another thing I designed and printed with my 3D printer. And this will actually come up in the design for manufacturing discussion. It's reusable. It clips onto the top and it just holds my headphones. I have another configuration that holds like my keys and my sunglasses and that kind of thing. So we'll see this model actually a little bit later. And again, as I said, I spent some time doing metal fabrication. So this was one of my most recent projects that kind of came to a head, but I designed it in SolidWorks using weldments. And so basically you can buy extruded metal. So it'll have like a profile, this is like 2 inch by 1 inch rectangular profile. And then basically you draw like a skeleton sketch, and then it'll extrude that profile along that path. And it's really cool. And then you can generate a cut list, which that in the past took a long time, just handwriting out. Like you need, 7 pieces at, I don't know, 18 inches long, and there's this angle on each end. SolidWorks handles all of that for you with a couple clicks of a button. It'll tell you it'll generate a cut list for you. With solid bodies. So that's actually, if you guys are familiar with multi-body techniques, SolidWorks Weldments is a multi-body, not an assembly. Real quick, take a screenshot of this. This is going to be how you guys get tech support. If you guys are having issues with installs, don't reach out to us directly. We would prefer that you reach out to your tech support at ASU, because you guys have a VPN to get in to access your network license manager for SolidWorks, because you guys are on a network license. So there's that. And then there's the student support as well through SolidWorks. SolidWorks has their own tech support, so you can go to solidworks.com and student support and get the downloads there, whatever. There's the other training sources, which would be like my.solidworks.com. Now that all that's behind us, we have the agenda for today. So the two topics that I have are the SolidWorks refresher and design for manufacturing. These are the things that I think will benefit you the most for for your modeling in SolidWorks. Is everybody has to make changes or edit and repair. I swear I had to change my model 6 or 7 times through my senior design process, and it was annoying every time I had to make changes with fixing references and things. So hopefully I can help clear that up for you. Then I'm going to get into configurations. We're going to do some part configurations and see how that can be used and leveraged, and how powerful it is. Display states and appearances. Another really cool tool that you guys are going to want to keep handy is Visualize. That's a SolidWorks product, and that's what makes these really cool images when they're not actually real yet. So this is, again, companies use this to save money. They don't have to have these huge photo booths and get a prototype off super quick and pay for that cost when we can just basically create it and make it actually look real. We'll go through some display states and appearance settings and apply some appearances and add a few display states. And we'll know the difference too between what's captured in a configuration versus a display state. Then I'll get into more of a concept designed for manufacturing. This should be basically, you're going to discover this is what occurs in engineering. And if you're creating a product to be manufactured, I'm going to do my best to give you advice on how to create your model so that it can get to manufacturing in the cheapest way, or in the least expensive way, and user friendly. Editing, repairs, and design changes. We're going to go through some part editing, and basically, I like this plot here because it shows you how expensive it is to make a design change when you're in the manufacturing process. So I did a competition at ASU. I was part of a club called Next Level Devils. I highly recommend checking them out. We did a competition where we had to create an anchor in like a regolith material, well, in like a really soft sand. It would hold down like an astronaut in really soft sand. And we had tested our design like 7 times in a pool, and just things failed, things broke. You got to test it multiple times before you get to the point where you're like, okay, I'm ready. I can manufacture this thing, and break it, and then fix it, and then make sure it doesn't break again. And I think ultimately that gave us the advantage, because when it actually came time to test our product in the neutral buoyancy lab, nothing broke, nothing failed. It had the second highest pull force for keeping somebody on the ground, but the one with the highest pull force, well, the little thing that was attaching to the astronaut broke. So I say that we won that one. So yeah, make sure you guys spend time testing your design and prototyping. All right, so let me go ahead and open up this part here. In SolidWorks, this is my favorite thing here, is this new recent tab. In 2019, you could have like up to 100 items in your recents tab. So these are just any documents you open in SolidWorks, they go here, and then you can easily access them. So this is going to be the first part that we're going to work with here, and we're going to make a change. Well, something that commonly happens is you get in and you need to modify that first sketch you made. And you're like, I got to change this thing. Well, let's talk about this real quick. So this is line 1, and this will be line 2, or line 0, line 3, and then line 2. So it goes 0, 1, 2, 3, like that. So they already have those references. So we're going to come in and we're going to delete that line because we needed to delete it for whatever reason. And we're going to make a change. And then we're like, oh, well, you know what? We want that line back. So I can click L or click the line tool up there, and I'll put this line back. Everything should be fine. So I'll exit the sketch, and I get this error message, this warning. And we've all seen this, so we can stop and repair, continue, ignore. I always do stop and repair, and it rolls you back. Each one of those lines, when I extrude that up, let's just roll back up ahead of this. When I extruded that box up, well, those have an associated face. So this would be face 0, face 1, face 2, and then face 3, and then we have 4 and 5. So it's really, it already has what I'm going to refer to them as children. So the parent was the line, and the child now is this face. That's that reference. So we'll scroll down and we'll see our next problem here. So we see, if I just hover over this, there's a lot of information going on here that we just kind of get click happy and we're just like, I need to fix it. I'm just going to right click edit. Well, slow down and read it. And then also these blue and purple lines that you're noticing, those are the parent and child reference. And how you turn those on, those are up here. Dynamic reference visualization for the child and parent. Um, so those are telling you references that those are important. So it says we need to fix these dangling dimensions. So we can go through, and I'm sure you've done this. We'll edit the sketch. Well, when you're editing the sketch, the dangling dimensions kind of get this weird color, or anything that's broken. You can actually fix it without deleting that dimension and adding a new dimension. If you just select the dimension, it'll highlight it in red, the problem right here that needs to be fixed. So you can grab it and then simply just drag and drop it back onto the original line. So we know that dimension was linked to line 1. Well, so this is the first child that got messed up. So we fixed that child. Okay. And then we can see here this coincident relationship and this coincident relationship are that funny color as well. So I can select it and then it's red. So I can click, once it's red, drag off, and I can tell it where I want to put it back onto. So I know this point was coincident to this line 1. So there's another child. So that's fixed now. So that color over there and the relations is fixed now. So I got one last one. So I'll select it again. And it's red and it's got that midpoint that's broken. So we can drag and drop it back onto here. And now it's fixed. I have a fully oh wait, let's see. So what I typically do too, if it's blue and it's underdefined, you see down here it's underdefined. I typically just grab something and I'm like, oh, okay, it's not where I want it. So I can grab this and then drag it. Once that wakes up, it kind of snaps into place like a magnet, and then it's gonna, that yellow mark next to my cursor saying it's gonna add a coincident relationship to that midpoint. So there, it's coincident, and now it's fully defined. I can click the green check, exit the sketch, and it should be, it's not fine. So we can go back and we can fix it. So now it says what's wrong. Right click it, you can say what's wrong as well. Pull that up. Could not find the face or plane. Well, that's because face 1's gone. Face 1 is no longer face 1 because line 1 no longer exists. We have line 4 now or something like that. So let's right click our sketch and we can actually update the sketch plane that sketch was created on. So this is that sketch here, and it was created by just selecting this face and creating a new sketch. So right here we can say edit sketch plane. So it says missing face, face 1. That was the parent. Well, that parent's dead and gone, and the child's orphan, and the orphan's like, I don't know where my parents are. So I'm going to select face 2. That's the new face that it's called. Okay, you're fixed. You're good. Let's move on to the next thing. And this is the process you want to work through when you're repairing your model. Go to the top features that are broken. The first feature that's broken, and fix it. Most likely that will solve like 5 problems down the line. So when I drag this roll bar down, it'll potentially fix some more problems. Well, so this one's still broken. So I'm going to roll back up to here, and this counterbore's broken. This is a hole wizard hole. And it's saying that it could not find the facial plane. Okay, that makes sense. It was probably sketched on this face 1. So we'll just update it now. Give it the new face. And then we're like, oh, that's fixed. Let's go to the next one. What's broken here? Cut extrude. Oh, that sketch was probably created on that face as well. So, oh, it's got broken dangling dimensions. Let's repair the face first. So that's updated. Does that fix it? Nope. So let's stop and repair. That sketch has got those dangling dimensions. So let's edit the sketch. So I know this dimension here is broken. I'll select the dimension. And then I got this little dot here. I can drag and drop it back onto there. That fixes the dimension. And then I got this coincident relationship. So I can select this red dot here, drag it off, drop it back on. It's fixed. Boom. Fully defined. Everything's black. Everything looks good. Go ahead and exit the sketch there. Scroll back down. that hole's fine. Those are the two holes on the top. Nothing changed there. Fillet 1's broken. Here's a cool new tool for repairing. So the edge is missing because line 1's missing and all of its children are gone. We're aware of that. But new, I think it's like 2020, 2021 this year. If I right click, there's an option to clear all missing references if you just want to like delete them from there. Or you can try fixing it. So we'll say repair. And that worked good. It repaired those fillets, so that you can always try that. If you guys make changes to your sketch and you need to repair your fillets, go ahead and try that repair option. It may not work, but if it does, sweet, you're done. Click the green check and move on to the next thing. So we'll roll on to the last object here, fillet 2, and I'll go ahead and fix that last one. This line's missing here because that was a child of line 1 down here. And we can do repair. It won't work. And then just clear. And I think it's still fine. So just click the green check. And now our part's fixed. But it has like cousins as well that are, let's see what its cousins look like. So we'll go over here to the home tab, go to my recents, and that part was in an assembly and a drawing. So let's go ahead and open up this assembly. Hopefully everything's fine now because I fixed it. So it should be fine, right? We'll rebuild it. And as expected, it's colorful because there was a coincident mate that was holding these two faces in line, which you can easily fix here from the context toolbar and just add in a new one, and then you can get rid of that original one or whatever. So you can also open that mate up, edit that mate, and clear these out and just select the new faces and fix it that way. It's one way to do it. So you fix that, and then you got to go to even more. Now you got to fix the drawing too that you broke. So you just got onto this new job and you're playing around with the files and you deleted a line, and now your boss is after you because it's this nightmare. So don't delete the lines is the no. But just be careful when you're making changes. Because we can see all these dimensions now have that funny color as well. And if I select this dimension, I get that red little dot, so I can go through and spend a lot of time reworking and fixing everything. So how do we solve this problem? Well, there's one cool little nifty trick that if you're going to be drawing new lines and replacing that, let's just take a look at what that looks like. So I'm going to hit Control and press Tab. Pops up this, while I hold Control down, it pops this thing up. And I'm going to press Tab until I get over to my part to open up my part. This is one of the most useful things that you should take from this is file reload. File reload will reload the file from when you last saved it. So I'll click OK. It's going to say, do you want to discard all these changes you made? Yes. And reload it back to originally what it was. Okay, so let's see if everything's fixed now because I left some stuff broken. This drawing should be fixed after it loads and rebuilds. Let's do a quick little rebuild there. I'll just close it and not save it. All right, let's go back and make that change. So we'll go into Sketch 1, we'll edit Sketch 1, and instead of deleting the line, go ahead and draw your new geometry. So let's say we needed this to be out here like this, and then come over here. And this was the new line, basically. So you know this is where this line, you're bumping this out here. You can left or right click the line that you want to replace with a new line. And from the context toolbar up here is going to be replace entity. And it shows like a little arc moving to a line. So you select that, it automatically selects line 1, and it says replace this entity with this entity. So go ahead and right click that green check there, and I'll fully define it just so we have that as well. Actually, I'll go from here to here, and let's say, I don't know, 1.75, and make this thing 3.5. All right, and I'll just say these are equal. So I can hold down Control, select both, and there's make equal. And it's fully defined. Okay, let's exit this sketch and see what it did to our part. So we have one error. So it's stop and repair. Well, it drops it down, and it's just these fillets. Then that's because there's two new faces here. So those fillets that were around only 4 edges now have 2 new edges, and it obviously doesn't know how to handle those new family members. So we can try repair all missing edges. And then I'll select the 2 new edges. So that's one way you can repair that. And then we'll scroll down, and that one's fixed. So let's go ahead and open up now the assembly that we were looking at. So we'll rebuild that one, and the relationships are the same because the face one, the parent was given a new parent for the children when we use replace entity. So those are going to be the design techniques that you're going to want to use is replace entity. Be aware of when you're changing out lines or deleting things. Do not delete things. I highly recommend not doing that because it can cause problems. Also, before you make dramatic changes, save off a copy and make your changes there. And you probably are aware of that. And that's probably where a lot of these file reference issues come in. All right, so the next one is going to be for configurations. We're going to see how to use configurations in a part and how it would apply for like creating this, and then take a look at the design table real quick and some other ways to manage your configurations. So we're going to take a look at this ratchet handle here. This ratchet handle would be an ideal candidate for something to be casted. So we're going to make some new configurations that are for casting. So this is going to be the final machine product that we designed, and now we need to create a version of this that we can send off to our person who's going to create a mold to cast this in. So I'll go up here to the top. This is the configuration manager, by the way. So let me just start here. This is the feature manager design tree. Property manager, this comes up when you choose a command. When I click that, it jumps to the property manager. Configuration manager is what controls your configurations. And we'll get into this a little bit later. We'll right click the component and say add configuration. So the configuration name is going to be forged long. And we're going to also have a short version of this as well. Sorry, I kind of clicked fast. I was just going to leave everything else as default for the configuration, but the forged long one is active now. We can tell that by the green check. And what we're going to do here is we're going to go back, and we don't want this pocket feature anymore. We want this to be a flat face. So I'll select recess here, and I know that recess feature is the one that I'm probably going to want to suppress, and I can see that it's got 2 children. So we got pocket and ratchet hole. So I know I'm going to lose those 2 children when I suppress this. So I'm going to go ahead and suppress this feature here. But it also suppressed wheel hole. That's because wheel hole's parent was suppressed as well. So when you suppress features, you lose the grandchildren too, if there's grandchildren, and the great-grandchildren. So any of these features that you suppress, like kind of higher up here in your feature tree, well, they have children and grandchildren and great-grandchildren, and you're going to lose all of them when you suppress that. So just be aware. And that's why it's always handy to have this dynamic reference visualization for the parent and for the child turn on. Parent's blue, child's purple. And that all I'm doing here is from the feature manager tree. That's this feature manager design tree. I'm just right clicking here and I'm selecting these 2 and turning them on. All right, so there's my forge short. I'm going to go back to the configuration manager, and I'm going to create some new configurations. One cool thing is, since SOLIDWORKS is Windows based, you do get all of the Windows functionality. So like Control C to copy and Control V to paste. So I'm going to select default here. It's highlighted in blue. Press Control C to copy it. And then I'm going to click here in the configuration manager and press Control V. Well, actually, let's rename it. So we're going to name this one machined long because we know it's already set there. All right, and while I'm here, I'm going to make a copy of forge long, Control C, Control V, and we're going to name this one short. So it'll be forged short. And then I'm going to make a copy of machine long and make a short version of that one too by pressing Control C, Control V. And then also you can do the slow double click to rename it, or if it's highlighted, you can press F2. So that was something I learned a little bit later, but F2 is rename. So it's either slow double click or you can press F2. And this is going to be machined short. For machine short, let's go ahead and activate machine short. So the recessed feature is unsuppressed. All the children are unsuppressed. I'm going to double click this handle here to activate the dimensions. And I'm going to change this dimension to a shorter version. So I'm going to double click it. And this pulls up the dimension palette. And I'm going to change it to 180. Over here on the right hand side, that's one thing I had to learn too, is not to be so click happy. There's so much information in these dialog pop-ups that you can change. I can actually specify which configurations right from this dimension palette that I also want to be the short version. So I'm selecting forward short, which has the recessed feature suppressed, and I'm changing this dimension all within a couple button clicks to make it short as well. So I'm going to click the green check. It updates. I'm going to update all of them simultaneously. So I'm going to right click here at the top and I have rebuild all configurations. So I'm going to click rebuild all configurations. And notice I have a check mark next to all of them. So I'm going to go through and just test them. So machine short, it's shorter now. Forward short should be shorter. I'm going to come up here to this cool little toolbar and I'm going to select forward short. Recessed is good. Machined long gets longer, and forged long. So recessed is filled back in. Now I'm a little bit unorganized as well here too. So I got forged long, forged short, machine long, machine short. Well, I don't have to go through and organize it. I can actually right click up here at the top, and down here is tree order. So if I select literal, then that organizes them for me automatically. So I got all my configurations created and organized pretty quickly and easily. This little toolbar, if any of you guys are wondering, you guys can turn that on. I use it a ton because I make a lot of configurations. So if you just right click up here in the command manager and you go to toolbars, this will pop out. Over here on the left, it's in alphabetical order. You'll find configurations. When you turn that on, that'll turn configurations on. Another useful handy one is selection filter. That's this along the bottom. And I most commonly go for this one, selection for line edges, for selecting edges that are kind of hard to select. That you'll probably find useful when you're modeling. The selection filter and configurations are the two that I recommend. Alrighty, well that's configurations for you guys for part modeling. Display states and appearances. So we're going to first talk about display states versus configurations, what can be captured in a display state versus what can be captured in configuration. We'll see that method. We'll see some selection methods that you might not be used to that are pretty useful. And then we'll take a look at appearances and materials and scenes. So let's go ahead and jump into this model here. All right, so when it opens up to the configuration manager. So I'm just so we're kind of used to the typical thing, the start off here in the feature manager design tree. If you want to change your display states, that's going to be in your configuration manager. It's down here at the bottom. Some things that display states can control would be like hiding or showing specific components, the appearance of components. You can also just define the display style. So if we go to hidden lines removed or hidden lines visible, that will be captured here in the display state. So you can change that based on or display style. You can capture that in the display state, and then the transparency too of components. For configurations, that's going to be part configurations can be stored here. So if this part had different versions, or if there's batteries on the inside that had different configurations, that can be controlled by a assembly configuration. And then component positioning, we'll see that one. And yeah, so let's go ahead and get started here. Let's right click. I can right click anywhere in the configuration manager to add a new display state. So I'll add a new display state, press F2 to rename it, and I'm going to name this one external parts. And I'm going to select all the internal components and hide them. So up here at the top, probably never select this, but this is where your selection manager is. So you have different methods of selecting things. So you can select by volume, suppressed, hidden. Again, check out the help on, just type in it, selection method help SolidWorks, and that is going to tell you what each one of these does. And I'm going to go through some. So I'm going to select internal components. Well, obviously nothing should change since it's all inside. So I'll go here to my feature manager tree, and I can see that I got batteries highlighted. And also if I drop this down, inside of the bulb, or inside of the head subassembly, is a light bulb and reflector. So it captured all of those with just one button click. So let's just go ahead and take a quick section view and see what that looks like when we select them. So I'll select here, and I will say select internal components, and as you can see, it selects all those components. So then I can right click, hide, and that will hide all of the internal components. So I'll exit this here. They're still hidden. Come over here, and for external parts, that's going to be all the external parts. I also like these shortcuts, keyboard shortcuts. So Control 7 is isometric. So I press Control 7, that's going to give me an isometric view. So if I press Control 1, 2, Control 1, that's going to be front. Control 2 will be back. Control 3 will be side. Control 4 will be the other side. All right, so Control 7, that's just keyboard shortcuts. And how you find those, you right click up here in the command manager and you go to Customize. And then Keyboard right here. So you can set it to commands, and then you can search your commands, like center line. That's one that I always change. And then you go here. If you want to set a command, just press it on your keyboard. So if I press Alt L, let me just delete it out of there. And I press Alt, I select in that box and press Alt L, it'll automatically throw it in there for me. L is going to be your line tool. So if I look up line, it should be line. There should be line is L. So order isometric should be Control 7. So that's where those are stored. Is here under keyboard. So how I got there, right click, customize, right click in the command manager, customize, and then we go to keyboard. Mouse gestures are going to be another one you might want to modify. There's these. But play around with those. Shoot me an email if you have any questions about them. All right, so we have external components selected. Next, I'm going to go ahead and add some more configurations. So again, the Control C, Control V works. I'm going to select Display State 1. That's going to be, if I'll activate Display State 1, that's going to be no internal, or everything's there in Display State 1. So I'll press Control C, Control V, select it, Control C, Control V, makes a copy of that display state. This one I'm going to call head, and I'm only going to capture the head in this one, and then paste another copy, and this one's going to be body. All right, so I'll activate the head, and I need to select the entire body. I can go through and select each component, or try to select the components and hide them. One cool option for hiding things that most people aren't aware of is Tab and Shift Tab. So if I press Tab and hover my mouse over components, it'll hide them. And then if I hold Shift Tab and just hover my mouse over these components, it'll unhide them. Let's go here and see there's still batteries not hidden. So I'm just going to unhide that, and everything else is unhidden too. All right, so I want to hide the body though. So an easy way to do that is I can right click head sub, and up here at the top is invert selection. So that's going to select everything except for that subassembly. And then I can right click and hide. So everything's hidden there. Let's make sure I'm in the display state for the head. Yep, so there we go. So that's one easy way to hide that. Now display pane, that's this little button up here. Most of the time, I didn't even know this thing existed for like 6 months after I started working for GoEngineer, because my feature manager was always like this, and you don't get that little drop push out arrow. So if you drag this out, you have this little arrow here. This is going to open up your display pane. This is useful. It tells you here in this column all the things that are hidden. In this column, it tells you the display style. So everything here is shaded with edges. It tells you the color for the appearance. And then if you set anything to be transparent as well, it'll appear transparent. And just by clicking in that column, you can change it as well. So there's little drop downs here as well. You can change it to hidden lines removed just from there. So this is a really useful tool up here, display pane. All right. And again, let me just pop back into this slide here. So this is the display pane that I just showed you guys. You click that to expand it. As I had mentioned, we have configurations, what you can capture in a configurations versus what you capture in a display state. And then this is from the help guide, and this explains what each one is. There's hide show, there's display styles, which is not there. There's like another one that I didn't grab. But if you just type in display pane, help, SolidWorks, it'll pull up the help for the display pane. All right. Let's go back to this configuration manager here, and I'm going to activate body, and it should be it's a copy of display state. So now I'm going to want to hide the head and just have the body. Well, we know that's easy to do here, so we'll just go ahead and hide this body here. So next, let's just make one last copy here of the body. So I press Control C, or I can right click and click copy, and then I can click here just in this configuration manager and press Control V, and it's going to be a copy of body. So it's going to copy that display state and everything's hidden. So I'm going to activate this copy of body, and I'm going to name it to, let's say, body HLR. And HLR is for hidden lines removed. And I'm going to set some components that I want to have hidden lines removed. So let's say this holder and this clip. And let's see. No, swivel might be fine too. You can just select components, but I kind of want to see these batteries. So I'm going to select all those. And then I'm going to right click one of the highlighted options. And then I'm going to go to component display here. And then I'm going to change that to hidden lines removed. Notice these updated here in the display pane. In the graphics area, I have hidden lines removed. And so now I have a new version of this hidden lines removed. This is going to be great for creating images and updating your images in your technical documentation that you're writing for your senior design or things that come up with the model that you're using. That's the whole point of these display states, is to easily jump through, capture images. You make an update to the head here, you easily can just jump to that display state. You want in your drawing, you want all the external components, or you're sending it off to somebody, and you don't want any internal components because that's proprietary. This is a display state. Capture that. All right, so let's create a configuration. So right click, add configuration, and we're going to say rotate clip because we want to capture a clip that's rotated. So it creates two new display states. That display state that it creates is going to be the display state that you had highlighted when you created the new configuration, or you had active. So I had external components active. Went from the default, I created a new configuration, rotate clip. This display state is going to be external components only. So I'm missing the batteries and light bulb and reflector. So just be aware of that. And then it also names one with the configuration name. I'm actually fine with it there because I'm only rotating this clip down. So I'm going to rename this here and just get rid of that and that. And that's what I want the name to be. And then I'm going to select this. And this was new in 2019, breadcrumbs. Show breadcrumbs at mouse pointer. But up here in the top left, these are your breadcrumbs. And these are going to be your mates. So when I selected that, if I select just this component in general, this is going to provide me all the information. The mates that are constraining that clip down. So it's got a concentric mate. Notice it's highlighting there. It's got a distance mate as well. And then it's got this last clip gap distance mate. That's the one that I'm going to want to change or just suppress. But it also provides me all this other really useful information that all the way down to the sketch that created that feature, that extrude thin on the clip. I'll go ahead and come up here and right click and then suppress it. And this is all from the graphics area, and that suppresses that clip. Now I can grab this clip and move it around. So I'll drag it down here. That is going to be rotate clip. I'm going to press Control 7, and then I'm going to activate this. And it's going to be the same. The display so anything that was changed in the configuration level, like component positioning, that's going to be locked to the configuration. So when I go back here and I switch to default, the clip is going to snap back into place. So here's something that you guys also need to be aware of. When I go to rotate clip, that mate is suppressed, and I have this sweet display state. When I right click and go to properties for the display state properties, there's this option here, link display states to configurations. If I turn that off, the display states are going to not be linked to any configuration, and you're going to have now a full list of all the display states. But the clip is going to be down because now it's no longer linked to a configuration. So it's going to be down in all your display states. So be aware of that, because if you are repositioning components and making different configurations for each one, somebody gets in your file and is like, oh, we go to properties here and I'm going to check this box here and see what happens. Don't just do that. Or now you're aware of how to fix that. So when I check it back, it fixes it and it's back to normal. And now the component positions are back to normal for my default configuration. All right. That's all I have for you guys for display states and appearances. We're now going to transition. We have 30 more minutes. We're going to transition over to design for manufacturing. I really like this quote. The best design is the simplest one that works. And try to keep that in your mind, or just lock this little image in your mind if you can when you start your design. And don't worry about if it takes 7 iterations to get to the simplest design, but do your best to get there. So for design for manufacturing, the first topic that I said was going to be minimize. So we want to minimize the total number of parts it takes to create your assembly. That is just reduces a huge cost. Same with fasteners. Surprisingly, that's like the number one thing, because you have to source those fasteners. You have to keep that vendor as one of in your vendor list. You may have multiple vendors for your fasteners because some might be out when you need them. You have to maintain those on your shelves, and we'll get into that a little bit more. But that's kind of, I know it sounds silly for fasteners, but there's good and bad, and we'll explain that as well. Reusing. So there's going to be standardizing parts. By standardizing parts, you can reuse those parts. And then I'm going to talk about design library in SOLIDWORKS. So how does this get back to SOLIDWORKS? And so basically, if you're going to spend the time designing a new component, make it reusable, make it versatile. So that's going to be for standardizing parts. And then if your manufacturer has standard tools, like you're a sheet metal house and you have punches and louvers and all these different types of things, or you have CNC and you have these specific drill bits that you commonly use. Drill bits are really expensive. Same with lathe components; those are expensive. Those little bits, and you want to keep those in your design library. Things like that, and I'll get into more detail about that. And then we're going to get into design intents and talk about components that just easily fall into place, like consider assembly line. People are assembling your product. You want it to be easy to assemble, and you want symmetric components. That way you can have instead of having a left hand and a right hand, you'll have one part fits in both spots. To keep those things into consideration when you're creating your design. And then lastly, I'm going to get into top-down design. So there's bottom-up or top-down. Bottom-up, I like to think of Legos. That you have all the components and you have assembly instructions. You're just assembling it. You're just adding mates, coincident mates, concentric mates, those kind of things. And that's a bottom-up design, and that's probably what you're going to get into when you get into industry, because most of the parts are going to be already made. You're going to be either making modifications or that kind of thing. If you're an entrepreneur or you guys are starting a new prototype of something, I would recommend a top-down design. And a good example of this would be like a robot arm, and you're designing attachments for a robot arm. You start with the robot arm, and then you build off of that. And that's top down. So you build components, you build a holder for like a welder, you build a holder for plasma cutter, and so you can interchange it, that kind of thing. So, um, so minimizing parts and assembly. Um, let's just this part looks simple. Kind of looks like a battery tray or something. We've got one rod right here. Um, but we have to now find a machinist or maybe like a welder that can weld on like a thick washer on both ends or something. And so now we have a new vendor, and we have to keep them in our contacts. We have 3 sheet metal parts here, so maybe we could get lucky and get all 4 of these components fabricated from one place, but most likely maybe 2, depending on the level of detail for this rod. And then the sheet metal house, depending on the tolerance, so how tight of a fit this, like whatever this thing fits into, wherever it goes, what's the tolerance? Like how much can this angle be off by? How much can this distance be off by? If it's sloppy, you probably can stick around with just one sheet metal house and have a press and just chop all the edges, boom, 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 put a bend in it, and they can create these 2 components. And then you have this third component that you have to create here, and that's another process. But they may not have, like, if you need a tight tolerance and it's fitting in, you have small clearances and small adjustment for this needs to be accurate, then you're probably going to have to go with like a water jet or plasma cut company to get this. So that might be another customer or vendor you have to keep in contact outside of your sheet metal vendor. And then you also have all the fasteners that you have to maintain and source and keep those on your shelf for the life of this product. However long you're selling this, you have to keep replacement components, so or replacement parts. So you got to stock all these on your shelf and keep all those vendors in contact. Make sure they have your parts when you need them. So this simple looking assembly actually can be very complicated when it comes to manufacturing it. And all this information, all this stuff should be considered when you're designing it. Um, this isn't a bad design, but there's definitely a more simple design. So we can't really change the rod, and probably could, but we have the rod, but we can reduce this down to 2-part assembly. So we get rid of the fasteners. This has hopefully one sheet metal shop to cut this out, and maybe a CNC shop. If this is going to be a stock piece, it's hardened steel or something, and they're going to, I don't know, that would be a lot of cutting, probably a huge waste of money, probably just weld it on. But this is the key concept. Um, I got rid of all the fasteners. I don't have to source fasteners now, and now I only have to deal with one sheet metal house. And they're just going to plasma cut these little bends in here, or these little rip edges here, which will allow this to flex. And you can just stick the rod in and pop it into place. And then these will be 4 bends: bend here, 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 and here. And so this is the major idea with reducing the total number of parts it takes to make your assembly. The other thing that I think of for reducing fasteners was the Japanese wood joiners. This is an example of a Japanese wood joiner, but there's this video here is another example of common Japanese wood joiners. And I think this is important. I think you guys should consider this if you're going to get into 3D printing. This could apply because your 3D printing bed is small and the object you want to make might be large. Well, what you have to do is break it up into components and then make them assemble back together. And that's what you saw with my 3D printed item. That I made. I used a dovetail. This isn't a dovetail, but these are just different examples of Japanese wood joiners that can apply to today's additive manufacturing. So additive manufacturing is 3D printing. And if you're familiar with CNC or lathe, that's subtractive manufacturing, meaning you're cutting material away. It is the opposite of 3D printing, but this practice has been around for a while, and the techniques can be applied to today. So if you guys are going to be 3D printing things and you guys want things to snap together, notice they're not using any fasteners to assemble their thing, whatever they're making. And this you don't have to spend a ton of time anymore cutting and creating this sweet object out of wood, because you can just 3D print that dovetail, and you can use a top-down design and use convert entities. If you guys are familiar with convert entities, for this part here, you don't even have to recreate the geometry. It'll update when if you need to update that dovetail, make it wider or whatever, or make it thinner. Then if you're smart with your top-down design, everything else will update when you make a change. So let me just jump back here into the slide. So this is that example that I created for my cubicle clip. It clips onto my cubicle and it holds my headphones. Um, some people in the industry, that's their go-to is I'm gonna put a fastener on this thing. It'll hold it down because I know that works and it's fine. Most of the time in like woodworking, yeah, it is fine. It's just put a fastener in it. But you don't have to. If you can get away with like those snap fit live hinges, get away with it. Use it where you can. So this took me like 3 times to get this right. I had this piece too thick. It wouldn't flex enough when you would grab it. I had the grip going the wrong way. I had these little like edges here going up for some reason, like kind of at a sharper angle, and I couldn't really reach my fingers through and grip it well, so I had to change that, modify that. This lip here was too far out, like and too strong, so it wouldn't come off easy. So I tested, prototyped with my 3D printer, created that design, and it worked great. And there's no fasteners; it can slide along my device there. Well, yeah. So there's one other thing I want to show you in there, and that's the dovetail. So I really like the dovetail, and I known about the dovetail prior to this presentation, so I had actually designed it in. But dovetails, I think, originated in with the Japanese wood joining. And that's the most simple one. It's commonly used by machinists. Um, so this is that component that I had designed to fit this the top of my cubicle. All I did was take that metal piece off the top of my cubicle, took a picture of it, imported that into my sketch. So let's see, where's that metal fixture? I'll open that part up. So if you guys, one easy way to replicate things, this is the top of my cubicle. In this sketch, let's see, there's a picture of it, of the piece that I created. So I took a picture on my countertop. Pay attention. See how you can see the surface? If you guys are going to be rebuilding things and importing in sketch images, if you guys first off want to know how to do this, shoot me an email. It'd be a different thing. But if you can see this edge, that most likely is going to give you an improper dimension when you put that dimension in and you're rebuilding it. So just pay attention. Notice you can't see the top. Like if I wanted to rebuild this countertop, that's the problem. But this, I was able to move my camera up and down until the top of this piece of metal disappeared. When the top disappears, your front on any dimensions, any building, any sketches you're going to make around, your image is going to be accurate. I've had to learn that lesson the hard way a few times. In fact, with the Google Home Mini, that was a problem. I didn't capture that at the right angle, and so my curvature was off. All right, so back in the assembly. This is the dovetail as well. So this goes back to that reuse. Making parts reusable. So I can reuse this clip. So let's hide this guy here real quick. So this is the dovetail. I can reuse this thing to hold different things. I spent the time designing it. I 3D printed it 3 times. I found out what was the best design for this thing to easily clip onto the top of my cubicle. Well, why shouldn't I make it reusable and so it can hold my wallet and my sunglasses and my keys and things when I get to work? And that's going to be the logic you want to carry with you when you're creating your component or your prototype or your assembly, whatever you're making. You're going to want to keep that in mind. Is this reusable? And ask yourself, does it need to be reusable? Maybe not. Maybe it's just a quick thing to get a quote in for something, a bit you're placing a bid, but that's where that rush gets in. You get a new bid that you want to win, and you rush through and you quickly mock build this thing up, and you got it. That's great, but now you got to go back and change it because the bid was just kind of preliminary. And then the next step, there's engineering change request comes down the road, and you're like, crap, I got to make all these changes. So the hard part is to slow down up front and consider these things that might be changing in the future. I could have designed this without the dovetail. It's one piece, but I would 3D print this bulky thing, and it could be this whole one big thing, and that's going to be awkward to put in a box to ship. Notice how things that you buy off Amazon, like furniture you buy, it can break down and fit into this small little box. Well, you got to consider that when you're building. Can this thing break down and fit into a small little box? And how can I do that? How can I make it break down? And or is this even going to fit on my print bed? I have a really small print bed. It's like, I don't know, 6 inches by 6 inches, and probably 6 inches tall. Like it's just like a little cube. So I have to break my things up, and that probably taught me that more about this design for manufacturing than I was aware of. So that's where these dovetails come into place. So that's the next topic. So again, to reiterate, for minimize, I kind of went ahead of time. I know I got about 15 minutes left of your guys' time. Thank you again for everybody attending here. Can we achieve these types of design by eliminating tolerances completely? You should always have tolerances, first off, and that's something that's really not taught in engineering school. But it was a rude awakening for me when I got out into the engineering field. You will always need tolerances, but especially in the Japanese wood joining type, those tolerances you want to be like you really got to pay attention for the 3D printing. That I wanted to slide off on and off easily, so I already knew the gap that I wanted. Like a 16th of an inch is generally like good enough. But you have to. There's things that you will find out over time, like how much is the plastic going to expand once it cools down when I'm 3D printing, because it's hot when it's applied and it cools as we go through. So yeah, that's those are things that you'll learn. So as they fit into place, actually I think it was a 30-second. There you'll figure those things out on um, as you go through on how to apply tolerances so that they're tighter or which one can be looser or the other. And I actually have a sheet metal part that I'm going to show that on. Um, so minimizing parts here, we want those to we want to make our assembly smaller because that's going to save us time and money for our vendors, for our guys on the assembly line, having to assemble more things. Like I don't need an assembly line for that second product anymore. They're just snapping a rod into place into flexible things. That other one definitely needed an assembly line. There's three parts that come together, and somebody's got to hold that one up, and it's going to be awkward. And how are you going to get that nut in? Are you going to build a fixture to hold it so it drops? You know, all that's added extra stuff. And if you just spent the time ahead of time and you design it properly, you're not going to have this special assembly line to make your product. So next is going to be reuse, standardizing parts and design library. So standardizing parts, this is going to be that common bolt size. So like when you're working on a vehicle, you might have noticed, like especially foreign vehicles, that you're commonly grabbing or you're working with M10 bolts, and this is done intentionally by manufacturers. They want this to be easy for their customers to use and to work on, and all the vehicle shops that are all the repair shops. When you go to work on a foreign vehicle, you're gonna you're comfortable with the M10, you know what size socket to grab, and you're ready to go and start taking things apart to rebuild it. So do that intentionally. Use common bolt sizes that everybody will have tools to work on it with, or they may even have their own spare components. Um, it's just that. So I know I talked about get rid of fasteners, but you can't always get rid of fasteners because we need to hold forces down. So if you can't get rid of the fastener and you need it, then use a common size if you can. That they'll have your customers or your end user will have tools to make changes to. So SOLIDWORKS Design Library. This is that thing over there on the right hand side. of your user interface that you probably don't touch, and it's this 3-book looking thing over here. You click that and there's this design library, and you never touch it because there's no reason to, and you go on with your merry life. But this is a very powerful thing that you should be using, and there's some cool stuff already built into there. For instance, sheet metal stuff. So you can add your own, and I have a couple good links for you guys on how to create these design library parts that are reusable in your parts. So when you create a part, you can literally like drag and drop a feature onto there that will cut out this complex feature automatically, and you just line it up, just like a hole wizard component punches out a hole for you, a cool hole. You can design your own specific little punch out or cut out thing. So let's take a look at that real quick. All right, let me go here to this working configs. So this is going to be a machine part, theoretically, like hypothetically, this was a part that needs to be machined. I'm going to send it off, and this is going to start off as a solid rod, however thick this is, 3 inches. That's a cool little trick too, by the way. Select an edge, it displays the dimension down here. So it's 3 inches in diameter. That's what it would start off at, probably more like 3 1/4, and they'll cut down a quarter to get this as a nice surface, and then they'll cut all this stuff away. And this is going to be for fluid power ports. So this is going to transfer fluid. So we need to design this special little port. Well, there's like a fitting, right? Like if you've ever worked with hydraulics or pneumatics, you know that quick, easy clip fit. Let's say that head we want to design. We know those dimensions, but we don't want to have to look them up and everything. Well, that could be put into your design library. So out of the box, this is what you're going to have in your design library. So I'm going to drop down and I'm going to go to features here. I'm going to open up inch, and then I have fluid power ports. This is all there for you guys. There's sheet metal as well, forming tools. There's all sorts of stuff. Check it out when you have time, but just pay attention on how to apply it. So this is a part that was created with those holes, but you add these dimensions and relationships to your sketches, and then it makes it easy for a drag and drop. So I'm going to just click, drag, and drop this onto this face here. When I let go, I can select a configuration. So when this part was created, there was multiple configurations made for this. So I'm going to choose 516, 24. And then this little pop-up pops up here, and there's, when you create that part, you select a reference edge. There needs to be an edge that this thing goes to. Well, I do. I have this edge here. So I select that edge, and it's going to center it up. And it's going to, there's most likely a coincident relationship or concentric relationship, meaning that this circle out here, this edge out here, I don't know why I'm not zooming in, this edge out here is going to be concentric, meaning to this circular edge. So that's how that works. That was all done ahead of time. This fluid power port's put in there. It's got all this extra weird geometry that I didn't have to go look up and figure out. It's all in my design library over here. And I just simply drag it, drop it in. Some have dimensions. We'll take a look at one that takes a little more work to place, but really nothing that much. And also pay attention to the feature manager tree. You get these little library feature here, and this is indicating that it's a library feature that you pulled from your design library. So if you get into one of those if you're working for somebody or working on a project with somebody, that's all that is. It's in their design library, and you'll know to ask whoever created that. So we'll drag this square one onto a square hole here, drop that in, and select configuration. And then it's going to say I need an edge to reference. So there's that edge, and then it highlights another edge. It says I need another edge to reference. So I'm going to select this edge here. This is where that edge selection comes in handy. So that way you're only selecting edges. I mentioned that earlier. I'll turn that off. And then down here, I have 2 locating dimensions, because you see how it's like kind of cutting into that part there. This dimension, if I select it, it'll highlight it here. It's probably too many things running right now, but I can center it up by putting it at a 1/2 inch there, and it moves the geometry. And then this one here, it's saying from that edge to the center, this was set up with that part that was created for this design library to reference a dimension, and it goes there. So it goes a 1/2 inch right there. So it's centered up. This was all created in. It's supposed to be user friendly for a large company, and you guys are using these fluid power ports all the time. hey, just throw fluid PowerPoints on these and send it off for review. So that would be something how this would occur. You can do keyways. That's another common thing used in engineering. So I can drag and drop this onto here, and you can see in the graphics area where it's going to be put. It's going to be put in the middle of the part. So I'm going to select that, and this select this plane here, and then I'm going to select a configuration for it too. So that's going to say that's going to be the width and thickness of that piece. And now it's saying find me an edge, a reference edge 3. So I'll select this edge here. Maybe I need to turn on edge selection. I noticed this one acted a little funny yesterday when I went to select this edge. Let's just try that again. All I did is just click escape, face 1. All right. Something weird happened the first time I had selected it. So then I'll select this edge here, and it's updated. Then this is in the middle, so it's showing you there in the graphics area that 2 inches is from that face to the center of this point here. So I can bring it in, let's say 1/4 inch away from the edge, pulls it out of the part, so now I can see it, and then I can drag this over here, so it says distance from end to face, so that was that distance, so it's a 1/4 inch to there, and then this slot width. That's, so if you're familiar with the slot tool, that's going to be the length of the slot. So I can set this, I can change this dimension here if I want to make it shorter. And then once it's set, it's all set. It's good to go. Those are some built-in tools that are inside the design libraries inside of SolidWorks. I highly recommend checking it out, especially if you're doing routing, piping, if you have like electrical wiring going into something that you're designing. There are tutorials that will walk you through it. I highly recommend the tutorials if you want to learn how to do this stuff. So you come here to tutorials, pop this up, and then you can go to advanced techniques, and there's routing. This would have been useful in engineering for me when I was going to school. Same with pipes and tubes. Any one of these, if you want to learn more about equations, it tells you the time frame. These are some good self-help. Check out basic techniques for sheet metal if you're doing sheet metal, weldments, any of this stuff. Sheet metal forming tools, that's the next thing we're going to get into. So you can learn more from these tutorials. They're really helpful. In your version, your help is not going to be a help sign. It's going to be over here on the left-hand side, most likely, because you guys are a year behind. And it's going to say help. You can click that help button. And from help, you'll see tutorials. So that's all I did. And then I'll pop it over. And also in these tutorials, it provides the files. So when you install SolidWorks, it installs these files that they use in these examples. So you actually have some SolidWorks files on your computer that you're not aware of, most likely. All right, let me close this out, and I'm done with this, and we're going to get into the sheet metal part. So this component here, this will be the end of the design library that I'll show you guys. So over here is going to be forming tools. And forming tools would be these cool little guys that you have on your in your shop. So these are stamps. So you have you have a flat sheet of metal, and then you hold it into this thing and click a button. I don't know if any of you guys watch 8 Mile with Eminem. That's what they're doing. They're stamping in car parts, and they have giant ones of these things, but most of the time your sheet metal shop will have small ones, and you want this in your design library because that costs, or if you create something in sheet metal and you design your own louver or your own stamp because you want it to be unique, don't be unique. Use something that's off the shelf, because that charge will come onto you, because the sheet metal shop has to send this design off to a machinist that's going to machine out this little thing for their punch to meet your unique little punch out thing that you made. Well, find out what they have already on their shelf and just reuse that so you don't incur that cost when you're creating your part. So for example, I'm going to create this cover and I need it to vent over here more on this side, and I've already reached out to my sheet metal guy, and he's got this louver that stamps this thing on at a specific width. So I have it designed. I put it in my design library, and I can just drag and drop it onto this face here. And then I can use this interface to get it all set up right so that it's where I want it. It's angled the right way. And then I can position it as well. I can use smart dimension, throw in some like geometry if I need to. So I can position it and call it good there. When I click the green check, it punches that in automatically. I didn't have to spend all this time creating that specific thing. I knew my sheet metal guy had that in stock, and he could punch it out for me. It works really well with other commands inside of SOLIDWORKS. So you can easily modify and add it in. Let's see, feature that I want to do. I'm going to actually select it from here so I don't select a face. And make sure it's a geometry pattern, and then click the green check. And just like that, I added all these louver punch outs. And you can even mirror it over to the other side. So that's all. I'm going to finish that with design library. That's the end of the design library. It's important and it goes unnoticed. So if you guys can take advantage of it, I highly recommend it. And we have some cool tutorials on our YouTube channel. If you guys are looking to do that, just search on our YouTube channel for Go Automate. All right, so the last topic we're going to get into here, or last two, is going to be the self-locating parts. I really like this example. Simply adding a chamfer to this edge is going to make this spring fall into place. And this is back to that assembly line. You design this great thing, but the assembly process takes forever, and now you're paying these guys hourly, and it takes them a longer time to get your product to the customer because there's little things that can be changed. Like this, if this is an annoyance, just make it longer so that they don't have to like drop it in and hope for the best. You know, left hand, right hand. Well, can you change your design so you only have one component on your shelf that you have to stock, maintain, and keep in your inventory? If so, do that. Save yourself time and money. Last thing is going to be top-down design. That was a drink it from a fire hose, but this is the top-down design. I started off with this bracket here. I reused my dovetail. So meaning I can interchange this with different things that hold different things. This holds my Sonicare toothbrush. This holds my toothpaste, the Sonicare heads, and then my razor blade. I did this in SolidWorks with Visualize. They have like this cool 3D printed texture that you can put on there for an appearance. So that's all that is, that weird texture you're seeing there. That's just a visual thing. You can play around with the thickness of the bump and all that. But anyways, top-down design. I started with this bracket here. I added the dovetail. Then I opened up a new part, and I used convert entities to grab these edges here, because that's going to stay the same from design to design. Then I did, and also this extruded length here, however long this dovetail is. That's going to be the same as well. Also, making parts symmetrical. This part here is symmetrical, meaning if I held this up to the wall, screwed the 4 holes in it, and realized it was upside down, well, it's not a problem. I can just flip it back over, and it's fine. And I don't have to re-drill new screw holes. So consider that stuff when you're creating your part. Can I flip this thing upside down if I need to? Or if somebody, if the user installs it upside down, are they going to be annoyed and have these holes and have to repair drywall with mud? So those are the first steps going into just designing this plate. Then designing this attachment here. And then another attachment built off of that. All right, I went 2 minutes past, so thank you guys again for your time. And I look forward to seeing you guys at the career fair in January.